Imagine trying to push a pristine 4K video signal across like 4 football fields of thick, heavy copper wire.
Yeah, good luck with that.
Right. And then the whole multi-million-dollar broadcast just fries because someone plugged a catering coffee maker into the wrong outlet.
Oh man, a total nightmare.
Exactly. Welcome to today's deep dive. We are taking you into the hidden hardware of professional broadcasting.
Yeah, the stuff you never see but absolutely rely on.
Today, we are looking at a product page from HDTVSupply for this highly specialized piece of gear. It's called the AJA FiDO-4T-MM.
Right, the 4-channel 3G-SDI to multi-mode LC fiber transmitter. That is a mouthful.
It really is. But our mission is simple, you know? We want to understand exactly what this tech does and why AV pros will happily pay $2,585 for it. So, okay, let's unpack this. Why do broadcasters even need to convert a standard video signal into a fiber optic one?
Well, it basically solves two massive physical problems. You've got distance and you've got interference. Because when you run traditional copper cable, the electrical signal just physically degrades the further it goes.
It just loses steam.
Exactly. But by translating that standard 3G-SDI video, which is, the heavy-duty uncompressed format pros using pulses of light, you can do these massive cable runs.
Wow, pulses of light.
Yeah, we're talking up to 700 meters. That's over 2,200 feet on standard OM4 fiber optic cables.
Or, I think 300 meters on the older OM3 cables, right?
Spot on. But what's fascinating here is that converting to glass also fundamentally eliminates a huge broadcast headache, which is ground loops.
Oh, ground loops. So trying to understand this, is standard copper wire sort of like trying to shout a message across a crowded, noisy football stadium?
That is a really great way to put it, yeah.
And so whereas fiber optic, since it uses light, is that like communicating instantly and silently with a laser pointer?
Yes, exactly, because copper conducts electricity, right?
Yeah.
So if a neighboring camera pushes a surge into the shared ground, it surges back and pollutes your whole video signal.
Like the stadium crowd noise just drowning you out.
Exactly. But fiber optic uses glass. It doesn't conduct electricity at all.
So there is no physical way for that electrical surge to cross over.
Right, which is exactly why that price tag starts to make a lot of sense.
Yeah, I mean, $2,500 seems like incredibly cheap insurance when a single glitch could ruin a massive live event.
Oh, definitely.
But wait, fiber is glass, right? So it's delicate. And a live broadcast environment is just, well, chaotic.
Well, it's totally chaotic. Muddy music festivals, crowded stadiums.
So how do you actually get a raw, uncompressed 4K camera feed into a strand of glass in the middle of all that?
Well, that is where the engineering of this specific AJA unit comes in. It actually takes 4 independent channels of that raw SDI video input.
Okay.
And it simultaneously encodes them into light over 4 fiber links.
Wow.
And it doesn't just send the pixels, which is the crazy part.
Yeah.
When you convert electricity to light, it's very easy to lose the invisible piggyback data.
Like the HDR, the high dynamic range color grading instructions.
Precisely. But this unit flawlessly translates both the raw 4K video and all that delicate metadata.
That is super impressive.
It really is. If we connect this to the bigger picture, it's an absolute engineering marvel when you look at its physical footprint.
Right. I'm looking at the specs here. It is just 4.6 inches long.
Yeah, it's tiny.
So I'm picturing something roughly the size of a smartphone, and it's pushing 4 separate 4K camera feeds.
Basically, yes. And it weighs just 0.8 pounds.
That is wild.
But that compact size is crucial. In a mobile broadcast truck or a stadium control room, rack space is prime real estate.
Right, you need to cram this gear into tight spaces.
Exactly, or even mount it directly onto a camera rig without adding any bulk.
Well, here's where it gets really interesting. Encoding 4 massive streams of uncompressed data into light usually generates, like, immense heat.
Oh, absolutely, and it usually requires serious power.
But this entire unit uses a maximum of only 5 watts.
Yeah, it's unbelievable.
It even comes with a universal 5 to 20 volt DC power supply to run it.
5 watts that's less power than a standard LED light bulb. Wow. Keeping the wattage that low means the unit stays incredibly cool. And that is absolutely vital when you're stacking dozens of them together.
Right, like in a tiny, unventilated equipment rack.
Exactly. You don't want these things melting down mid-broadcast.
So what does this all mean? Ultimately, this tiny 0.8-pound transmitter is the hidden backbone that allows for flawless 4K video transmission over nearly half a mile of glass.
Yeah, it really is the unseen foundation.
It's this invisible heavy lifter that ensures those gorgeous, seamless broadcasts you enjoy from massive venues don't just, randomly go dark.
Totally. And this raises an important question.
Oh.
If a 5-watt box, smaller than a paperback book, can seamlessly beam 4 simultaneous channels of uncompressed 4K video across a massive stadium without a single glitch,
Yeah.
well, how much other invisible, highly specialized hardware is quietly holding together the digital world you interact with every day?